Good morning, ladies and gentlemen. Welcome to today's webinar on the electric vehicle industry, where we'll delve into some exciting developments and advancements. Let's take a quick look at our agenda for today. In the introductory segment, we'll explore the EV industry in numbers, providing a comprehensive overview of its current state. Following that, we'll move on to part 1, where we'll discuss the role of elite cobots in the battery pack manufacturing process. Then in part 2, we'll shift our focus to the testing and assembling of EV accessories in Mexico. Part 3 will be an intriguing exploration of EV robocharging. And finally, in part 4, we'll have the opportunity to meet the cobots themselves. So without further ado, let's jump into the fascinating world of electric vehicles. Turning our attention to the electric vehicle market, a truly booming industry. According to revenue projections, the electric vehicle market is set to reach a staggering $561.3 billion in 2023. What's even more impressive is the steady annual growth, maintaining a commendable trajectory with a projected rate of 10.07% from 2023 to 2028. By the end of this period, the market volume is anticipated to reach over $900 billion, with an expected 17 million electric vehicles sold by 2028. If you're a visual person, take a look at the graphic on this slide depicting the global revenues for EV markets, showcasing historical and projected data up to 2028. It's evident that the future of electric vehicles is not just bright, but it's electrifying. Taking a front seat to electrifying these roads, we go to China, with a revenue projection of $292 billion in 2023. China is at the forefront of the electric vehicle revolution. This impressive growth can be attributed to key factors, such as supportive government policies, subsidies, and expanding the range of the mini electric vehicles, and the introduction of more affordable brands into the market. China's commitment to sustainable transportation is evident, and it's a significant player in shaping the future landscape of the electric vehicle industry. Now shifting our focus to the electric vehicle production. China is currently outstripping the combined output of other key players like the United States, Germany, and Japan, becoming a global leader in electric vehicle production. The turning point was in 2019, when China achieved a remarkable year-over-year surge of 46%. As we move into 2023, China is set to produce a staggering 13 million electric vehicles, solidifying its position as a global leader. This achievement underscores the country's substantial investments, technological advancements, and prioritization of sustainable transportation initiatives. Our next slide sheds some light on the market leaders in global EV sales. Currently, BYD and Tesla dominate the scene, with other contenders including German automakers such as BMW, Volkswagen, and Mercedes, as well as other Chinese manufacturers like GAC Aeon, SGMW, and Li Auto. The competition is fierce, but it's clear that BYD and Tesla are leading the charge. The dynamics of the electric vehicle market are evolving rapidly, and it's fascinating to witness how these companies are shaping the future of electric mobility. Let's dive into the first part of our agenda, where we'll explore the role of elite robots in the electric vehicle battery pack manufacturing process. Let's take a look in how elite cobots have taken part in the electric vehicle battery pack manufacturing process. The heart of electric vehicles are their battery packs. Most commonly, these packs are lithium ion, offering superior performance, efficiency, and safety compared to conventional batteries. These batteries are manufactured within gigafactories, large-scale facilities that not only produce new battery packs, but recycle the old ones, recovering those valuable materials. Positioned beneath the vehicle, these batteries consist of hundreds of cells organized into pockets, ultimately forming a unified large-scale battery integrated into the chassis. The battery pack is a critical component, and its efficient production is essential for the advancement of electric mobility. Let's explore how elite robots are playing a crucial role in the automation of the electric vehicle battery pack. A major Chinese battery manufacturer turned to elite robots as its automation partner, specifically deploying the EC series for the assembly and testing of electric vehicle battery packs. This deployment demands exceptional consistency, 24/7 operational efficiency, minimal defect rates, very high accuracy, and installation flexibility. The elite cobots are proving to be indispensable robots in meeting these requirements, ensuring the seamless and precise assembly of electric vehicle battery packs. As we move forward, we'll delve deeper into the specifics of this collaboration and understand how cobots are shaping the future of electric vehicle manufacturing. The deployment includes lowercase cleaning, inline module assembly, inline cover plate tightening, and end-of-the-line testing of these battery packs. Lowercase cleaning. Here we see it deployed in EC66 cobot. The end flange is equipped with a vacuum brush, and the robot is cleaning out these lower trays for loose debris, including dust or shavings that you don't want in those battery packs during production. The flexibility of this robot makes it to where it can do all of the motions at 360 degrees at all of its joints, able to reach into all the nooks and crannies of that case to vacuum out anything that may have fallen in there. And due to its lightweight frame and versatility in low profile, it's able to be mounted on a low hanging, lightweight frame upside down. The cobot is able to be mounted at any angle, and it being upside down like this allows it to be able to reach into the lower case without needing to be awkwardly mounted off to the side, restricting its range or reach. Next, we go into vision system integration with our EC612, one of our larger robots. Despite its larger size, it is still able to be mounted upside down above the battery pack. This robot is equipped with a 2D scanner. First, it scans a QR code. This means that the cell knows which battery pack it's dealing with for serialization and tracking purposes. That same scanner is also able to locate screw holes to perform a screwing operation along this battery pack. This large robot is able to reach around the entire battery pack, doing all of these screwings per pack with a 100 Newton force consistently applied at each point, with a high degree of accuracy based off the coordinates provided by the scanner, allowing it to repeat this process over and over again with even the slightest adjustments necessary to make each of these screwings happen. Next, we go to cover plate tightening. This cycle requires 60 screwings per cycle. So we employ the EC616, two of them actually, mounted opposite each other. These robots are able to communicate with each other using our very flexible SDK software package. The robots are able to know if the other robot is in its space, increasing safety and allowing the robots to prevent collisions. Each of them are mounted with a screwing tool and are able to do these 60 screwings per cycle without risk of collision or missing a screwing spot with very high accuracy. This not only reduces cycle time, but guarantees a much safer work environment. And finally, once these battery packs are put together, they need to be tested. We employ another one of our EC66s, mounted upside down with a device to plug into the battery packs to make sure that the connection is secure and that the battery packs are operating effectively. For the robot to do this, it needs to be incredibly accurate in order to line up the device with the battery pack, because any misalignment could cause damage. But thankfully, the EC66 has 0.03 millimeters of accuracy, and while mounted upside down, maintains that accuracy, as it is able to plug into every battery pack without missing a beat. Next, we're going to move on to how electric vehicle accessories have been pushed with collaborative robots. Starting with Mexico. A confluence of factors have given Mexico a substantial advancement in the electric vehicle manufacturing. Firstly, they have a strategic geographical location of playing a pivotal role in the production of the automotive industry. Mexico has become a central player in the evolving dynamics of this global manufacturing, and this advantageous location facilitates efficient access to key markets and enhances the overall logistics of the electric vehicle supply chain. Moreover, the commitment of the Mexican government to foster a conducive environment for EV manufacturing cannot be overstated either. This provides a stable and supportive framework for investors, making Mexico an attractive destination for significant investments in the sector. Cost-effective resources further contribute to Mexico's appeal as an EV manufacturing hub, ensuring that they remain competitive and economically viable for companies to establish vehicle production facilities there. Additionally, the ongoing fragmentation of global supply chains has played into Mexico's favor. As supply chains continue to evolve, Mexico has positioned itself as a critical player, benefiting from the diversification of manufacturing operations worldwide. The attractiveness of Mexico is leading to automotive players not ignoring the advantages as they move their industries to Mexico as a strategic location, especially in the electric vehicle manufacturing. And lastly, the trade dynamics facilitated by the TMEC. Free trade agreement that gives another layer of appeal, fostering a seamless trade between Canada, Mexico, and the United States, providing a streamlined platform for the exchange of goods relating to electric vehicle manufacturing. Starting with steering wheels. Elite Robot was chosen by ZF, a global technological company based in Germany, with the objective of enhancing the efficiency, reduce labor costs, and improving the efficiencies of its plant in Mexico. Equipped with a screwdriver, this robot is doing screwing applications onto a steering wheel that will go into electric vehicles. In order to maintain a very high degree of accuracy, they are using our EC66 with that 0.03 millimeters of accuracy we spoke about earlier. This high accuracy, as well as the collaborative robot's built-in safety features, the collaborative robot is able to do a very high efficient task right next to human operators without risk of harming itself or those around it. Next, they took 2 more EC66s, but instead of just screw driving, now they're testing the steering wheels. This station would normally require 3 human operators. That has a high failure rate as well as a lot of points of failure for accuracy. So they employed 2 EC66s to test the buttons on the steering wheel so that the robots can engage with the steering wheel, see if the input has been reached, and then the robot can pass the steering wheel over to the other robot for final testing and inspection, cutting this down from 3 human operators to only 1 human operator, increasing accuracy and safety and reducing cycle time. Each of these robots are now communicating with each other through a user PLC and an external PLC, which not only gives constant communication, but ensures accuracy and safety on top of what the cell already installed. Next, we're going to move into electric vehicle robocharging. With more electric vehicles entering the market, that means more people want to charge their electric vehicles without having to get out of their vehicles and do it themselves. This brings in the ACR, the auto charging robot, not only increasing safety, but alleviating inconveniences caused by heavy cables, mobility barriers, dark environments, and it's adaptable to business operations. Elite Robot continues to contribute to cost-effective autonomous mobile robots, charging solutions maximizing the workflow with increased speed and accuracy. One solution was worked with Li Auto. This robot combines an EC robotic arm, a vision system, and Li's Auto AI algorithm to create an autonomous vehicle charging solution. This robot will use a vision system to locate your charging port on your car. Not only that, but it has obstacle avoidance. So if something were to get in the way or come near it, it would be able to avoid it and still make it to the plug. And once it's done charging, it'll remove the charging cable and it'll even close the cover on the charging port, allowing the driver to simply leave after they have gotten their car charged without having to do any hands-on work with the car charging process. To do this, the Li algorithm combined with the robot needs to achieve a docking accuracy of less than 0.1 millimeters. It has to do this autonomously without obstacle avoidance. But thanks to the integration of all these devices together, this is made a reality, to where the robots are able to auto-charge cars without a single person having to come up and touch them. Other ACR solutions with Elite robots include in the Tianjin Governmental New Energy Service Center, they launched a charging mobile solution in July of 2023, as well as a mobile solution in 2022 for e-cars and e-buses. Now we're going to meet some of the cobots that make up the Elite Robot catalog. Here on this chart, we show the CS series and our EC series. We offer a very wide range of collaborative robots, all the way from 3 kilogram small robots up to a 25 kilogram very large robot, with ranges down from 624 millimeters all the way up to 1900 millimeters, nearly a 2-meter reach with some of our robots. We offer our EC series, which is our lightweight, cost-effective robot, and our new platform-level advanced software and hardware version, the CS series. Starting with the EC series, our cost-effective original line featuring from the EC63 all the way up to our EC6419. All of these collaborative robots offer an IP54 safety rating, And they have communication protocols ranging from Ethernet IP to Profinet to Modbus, and a very friendly industrial teaching interface, very similar to common industrial language. And they maintain very high accuracies, all the way down to 0.02 millimeters of accuracy. A product highlight to keep in mind is our EC6419, a 1900 millimeter reaching robot with a 4 kilogram payload. Very good for effortless, long-range reaching operations, such as 3D scanning or quality inspection, panel lifting, or small-scale palletizing. And some of the other main advantages would be our web pendant, the ability for you to control the robot via a computer or using a separate PLC to drive the robot. Our rugged industrial teach pendant is very friendly to use, but we also offer the web version if you want to have a more computer-based operation. All of our robots come with collision detection, among other safety features, to allow safe proximity work with human operators. Our large range up to the 1900 meters means we can do anything from small scale, tiny micro work up to larger palletizings and more industrious machine tending. They're all flexible to install. Lightweight profiles can be mounted upside down on walls. They're very fast too, up to 4 meters per second of speed. The EC series has found itself in a proven track record among multiple fields, from small PCB boards of tightening screws on small little control boards, all the way up to hospital work in laboratories and wellness. They can do heavier duty work like palletizing, machine tending, welding, as well as more friendly exercises like fast food and catering, serving tea. The robots are flexible and diverse in their applications. Moving to our CS series. This is our newer line, higher IP rating, more user-friendly interfacing robot, with a ranging from a CS63 all the way up to our CS625. Accuracies all the way down to 0.02 millimeters as well, and speeds up to 3.9 meters per second. These robots are just as fast and capable as the EC series, but with a higher IP rating and a more friendly user interface, focusing on a more graphical interface, providing much easier understanding for those who are new time robotics users. That higher payload capacity offers even further range of options than the EC series, while still maintaining a very high degree of robustness. And they also maintain all of those communication protocols like Ethernet, Profinet, CC-Link, and that makes it very easy to integrate either a sole robot or part of a cell. These expandable platforms include plugins. They include talking to separate programs on a computer, such as Python scripts, Java scripts, C++, and C#, talking to other devices through Ethernet IP, RS485, or other common network protocols. The robots are very, very flexible. You can have just one robot by itself doing an operation on its own every day and any day, or you can put it as part of a larger cell, other robots, CNCs, even as part of a database if you're trying to track where your pallets are going or how many boxes it's processed. The robot is very, very capable of integration among larger systems. A CS highlight to talk about will be our CS620, a 20 kilogram, 1800 millimeter reach. Despite its long reach and high payload, still a 0.1 degree millimeter of accuracy. Up to 5 amps of tool power capacity, meaning that the tool flange alone can drive much more complex end-of-arm toolings, having multiple devices perchance added to the end of them. The CS620 is a very robust and very capable robot in larger applications like welding or heavier duty palletizing. But we also want to bring attention to our CS625, a 25 kilogram, 1500 millimeter reach robot, 0.08 millimeters of accuracy, and also maintaining that 5 amps of tool power potential. Our strongest robot with 1.5 meters of reach. This is a very robust and heavy duty robot, capable of even heavier duty activities. This robot is the current strongest one that the CS series has on hand. I would like to thank you all for your time today. If you have any questions, please feel free to reach out to us. We have contact information in the handouts. along with other information you might look forward to reading. If you have any questions regarding the robots, electric vehicles, or our work in electric vehicles, feel free to shoot us an email or leave a question behind on the webinar, and we'll be happy to reach back out to you and answer any queries you might have. Thank you for your time.